All right, welcome back to this class 505. As I posted, you guys have already one homework assignments, and since we didn't meet last week, but only online, but hopefully you reviewed the syllabus. Basically, this is a special course for those who needs refresh their computer science background, or for those who do not have computer science concepts and skill sets at all. That's fine, because this is designed for those students. And most of our students do not have strong coding skills or computer science concepts or understanding. So somehow the students are uniform. So you guys, if you want to be an expert in computer science and cyber security, this is good time that you can reset yourself to put more effort, more time on this class. This is very, very important class. If you complete this class successfully, then I guarantee you would not have any issues at all taking any additional advanced courses, not only here at Mercy University, but out there. So please follow my lecture thoroughly. Do not miss any single points. Even if it is the case, please let me know early so that I can record and make the video lecture available. Please do not pretend that you are in the major stream. If you miss anything for any reason, okay? So this course covers 4 major the courses usually covered in the computer science, coding, of course, and database systems, operating systems, and networks. But this class starts with operating systems very briefly. I know everyone knows a little bit of experience in using operating systems, either MacBook or Windows. For those who are using MacBooks, I want you to look into the Linux, the operating systems, because the Mac OS has Linux running under. Therefore, Mac OS is robust and also expensive, and right, compared to Windows systems. Those who are using Windows systems still fine. Don't worry about it. But for cybersecurity or computer science technologies, more focus on Linux rather than Windows. Windows is a very ad hoc, less organized the operating systems. Windows system has been caught up much more than 10 years ago or 20 years ago, but still its basis is not like Linux. Therefore, lots of issues and mistakes and errors. We all know, right? Windows systems, a lot of errors and a lot of damages and threats from hackers. But anyway, so operating system, somehow you guys know. You can follow the slide that I posted. Somehow your operating systems. If I can cover very quickly with you operating system provides you all kinds of management of your computers. And it is nothing but the program sets. Who coded the programs? Of course, if it is a Windows system, then Microsoft teams, there are thousands of the coders are developing, enhancing, or fixing, correcting the Windows operating systems. There's a lot of software packages there. Linux, the same thing. MacBooks, of course. So that is nothing but the software packages. If you see your laptop, then laptop initially is nothing, right? It has nothing. What operating systems needs to do is to help manage the activities that you want to do. First thing that one of the operating systems management is to load your program on the memory and get it ready. Memory means I think you guys all know that, right? Internal memory is not the storage. Softwares and operating systems stored on the storage, and when you turn on, then your software, first of all, operating systems needs to be loaded on the memory, and therefore anything that you want to execute should be loaded on the memory. If it is the hard drive, it's not going to run. Only it runs if it is loaded on the memory. So, but operating system is a software that can help any third-party software currently available on the storage, but to be loaded on the memory in order to execute. There's what part of the operating systems needs to do. But initially, operating system needs to be loaded. So who can load that operating systems? Operating systems can do it once it is loaded. But at the very first time, who can load that operating systems? Because there's nothing there. That is a bootstrap programs. Bootstrap. See, if you have a boots, you guys have a boots, right? It's a long, what is that? If it is a boot, then yes, yeah. So anything, because it is a long, it's not like sneakers or not shoes. It's not short, but it's a long. So when you first wear it, there's some straps. So you have to pull that, right? Something like that. That is hello.
I'll come back and fix that.
Later. So there's a bootstrap program is available. Where the bootstrap programs located? Is it on the hard drive, or it should be on the storage systems, or somewhere on inside your computer?
I think it should be in the memory or inside the computer.
If it is a storage, then software can do, right? Your operating systems needs to do. But this bitstream is a small program. Only what it can do is to load operating systems to the memory at the beginning. So this Bootstrap program is located on the ROM. Have you heard of ROM and RAM? RAM is a memory, random access memory. ROM is a read-only memory. What that means is that it is a loaded only. It's not rewritten unless you explicitly override it. But otherwise, it stays there all the time. So it's a read-only. So when you turn on your laptop, this Bootstrap program first loaded on the memory, and that Bootstrap bring your operating systems to load on the memory, and then your operating systems can help any other programs that you want to run. For example, you want to run a PowerPoint slide, then your operating systems can do. And if you want to print some of the files, then your operating systems can do. If you want to open up a web browser to communicate with somewhere, networking and emails, then everything that can be done by operating systems. So operating system is a big, gigantic software packages that can manage so many things that we human users needs to do, right? That is a big things. That is what operating systems can do. From security to simple management like printing or playing videos, listening music, and writing some documents, all things. So that is the Bootstraps. That's what I want to share with you. And usually these days, your laptop has multiple CPUs. You know, there are quad CPU, or some laptop has 8 CPUs. Multiple CPUs are running, right? So each CPU has a registers and cache memory. Cache is like a memory, like a RAM memory, but that sits inside the CPU. So we have a memory. See that on that here memory. This is a real memory. For example, 8 gig memory. Then that is a memory here. Your CPU has also a small memory called the cache, and it has lots of registers. What this cache can do is, if you want to immediately use some of the data to save access time from CPU to memory, even that short distance, if you want to save it, then you can bring that into these caches. But anyway, you don't worry about that. This is what operating system can do. But I wanted to see, there's something like that. Dual core design, then you have 2 CPUs. Quad core design, then you have 4 CPUs. And operating system is a multi-programming and time sharing. Memory layouts, usually operating systems sit on top, and all other jobs. Job is nothing but process. Process is nothing but a program. 2 programmers just program. 2 operating systems, that is called the process. In other words, some of the communication between devices, then there is a job. So printer job. So when you send a print, then printer has, oh, job 1, job 2, job 3. I have multiple jobs. But anyway, those are all piled up like this on the memories. And also, operating system has an interrupt. Basically, operating system is interrupt driven. There are two kinds of drivens, pole driven or interrupt. Pole and interrupt. Pole means, I want you to think of some of the services. In human society, if you go to, for example, some government buildings, okay? There are two types of services. When you enter that government buildings, all the government officers sitting there and waiting, they don't care who comes. They sit, they are working, whatever they are supposed to do. They are responding only if you interrupt. You interrupt that guy first. That's interrupt driven. On the other hand, when you enter the government building, so all the government officers are sitting there and they said, "What can I help you? Do you have any issue? What do you want to do?" They are polling you, P-O-L-L. They are poll you, right? So two different driven systems available. Which one is costly?
More costly, I would say, the interrupt or pole.
For government cost, not the client cost.
The pole.
Poll, right?
Poll.
Because everybody should. Oh, can I help you? Well, do you need anything? Everybody should say. They keep telling that, right? While they are working, they keep saying that. These operating systems. That's costly, right? They should always say, "Do you have anything there? Do you have anything there? Do you have anything there?" That is exactly for networking. Network connected to your laptop. Then your system should check. Is there anything that I can catch? Is there anything that I can catch? There's on network to catch some network data packets. Then your operating system needs to check. Is there anything that related to me catch? If they don't do that, that's pass by, right? Because they're all connected. That is polling. But other things, for example, when you bring up your web browser and then you want to print out. Web browser is running, right? You immediately, using some of the commands or a menu, you click print. That is interrupt, right? That's not, your program does not ask you, "Do you want to print? Do you want to print? Do you want to print?" It does not ask you to do that, right? Never poll you. But you have to interrupt it. So interrupt driven, less expensive. But there's lots of interrupt. If you send the email, then there's interrupt, right? Your operating system doesn't ask you to, "Do you want anything to send the email?" If there is polling systems, then operating system is really, really overwhelming, right? Do you want to print? Do you want to send email? Do you want to watch videos? Do you want to listen to music? Do you want to go to a website, Mercy University? Do you want to do whatever? How many different the point of interest that I have? Everything that every point then my operating system needs to poll me, then that is almost impossible, right? Therefore, there is interrupt driven. When I have something to do, then I can interrupt, right? Okay, you understand, right? Operating systems has a dual mode, kernel mode and user mode. Kernel mode is a more system intensive work can be handled in the kernel mode. Anything communicate between kernel mode and your applications where there is a user mode. But I want to see that this is a transition between user mode and kernel mode. Kernel mode, as see here, there is a blue box in the kernel mode. Usually that is a system calls. User mode is more related with your application program. Remember that I said the process is nothing but program. There's nothing but job. So user jobs. So user is working on some of the web browser, and the user you want to print, for example, some of the web page. Then user mode doesn't do usually the interaction with the external resources from your computer point of views. There's another mode called the kernel mode. The kernel takes in charge of communicating with others outside, printer or many other external devices, interactions. This go through that kernel mode. So your program, either by interruption or by executing your program, it needs to communicate with the external resources like printer or network. Every time, then you don't really need to care, for example, hey, I want to go to www.mit.edu. Do you know how to get to mit.edu? Really, literally, technically? You don't really do, right?
No.
Everything can be handled somewhere on your computer. There's a kernel. You can say, oh, very difficult system-dependent issues that can be handled by kernel mode. So anytime that you want to do such deep level activities, then user mode simply request that to kernel mode, like here. Okay, we call that transition. Same job, but that job needs to, at some point, go down into the kernel mode. The very same job needs to come back to the user mode. So it has somehow transition between user mode and kernel mode.
Does the user process always have to go through the kernel?
Right, without knowing, yeah, you don't really need to do. These things handled by operating systems. But I wanted to see there's two different levels of the mode, kernel mode and user mode, depending upon if it is a system calls. See here, system calls. Looks like this is more technical, right? Yeah, system calls needs to be handled by kernel mode. But lots of system calls required, involved. Anything communicating with the external resources, there's a system calls. Typically, if we have one CPU, one single process, then we have hardware, one kernel, and process like this. But now we have a virtual machine. Therefore, even if we have the very same hardware never changed. The same hardware, but on top we have multiple different virtual machine. Each virtual machine has its own kernel and then process. So the left-hand side, one kernel is available, and if multiple processes relying on one kernel, then performance is not really increased much, degraded. To improve it, we split the kernels. So while you are, for example, simple example is this. While you are working on Microsoft Word, you are typing something. On the same hardware, you have your web browser and some of the video clips. It is playing some of the movies. So you are watching movies. While you are watching movies, you are still working. Then while you are working on your Microsoft Word, there's one kernel here, and your video playing is another. It's not like one kernel, therefore time sharing. At one time, it allows you to type, and then while you are thinking, it playing. It's not like time sharing. They, as if each single process is running on its own kernels. Okay, this is one. Okay, there's operating systems, and then we had database. I ask you to install MySQL, the recent version of MySQL, either on Windows or Mac OS. Doesn't really matter. Only, yeah, you're working on the same MySQL database that can run on different platforms. Could be Windows or Mac. On this database, lots of concepts. What is a database? But we want to practice it today, hands-on. So, yeah, hands-on. So what I'm going to do, okay. Database. What is database? Database is somehow, actually what we are doing here, strictly speaking, database systems, database management systems, three different terms, strictly means differently. Database is a collection of data. Database management system is a collection of software packages. So MySQL is DBMS, Database Management Systems. One of the examples of database management system is MySQL. you already installed. So database is a collection of data. Database is somehow reflecting the real world. If you have data collected from registrar's office, university registrar's office, then that is a real world is a registrar's office, and then data collected from that registrar's office, that is a registrar's database. Suppose you have a database, registrar's office database, collection of data. You want to load that data using a database management systems, somehow software packages, so that it can handle some of the not only spreadsheet-like data collection, you guys know the Excel, right? Excel is like one page, one table, columns and rows. We do not call it database. We call it spreadsheets, right? One sheet. Database, you can think of multiple sheets. Each sheet can be a table, columns and rows. So you can think of multiple tables. If you're thinking of Excel files, then each spreadsheets not necessarily communicating with other spreadsheets. They are independent. But if you want to design a database for registrar's office or entire university or airplanes, ticket systems or customer management, or some companies, some government, some militaries, different organizations. Data that you can collect from that organization cannot be loaded in one spreadsheet, because there are lots of complicated different concepts of data, and somehow they are related. Supposedly they are all related, very complicated, but ideally this is a one table and another table and another table. So you could have multiple tables, but tables are directly or indirectly related. Suppose, for example, a student register a class. Then we have student data about students. Because I said classes, there's another data sets about classes, because we have so many different classes, right? IASP 505, 500, 510, 520, 525, so many things. Classes and students are independent, unless students register a class. That registration or enrollment should maintain the states of students' registration. So that could be another table, right? That table shows this student takes that course. Not necessarily that something about this student's iPhone number, this student's home address, this student's job data, occupations, or hobbies, or incomes, whatever, that all details that may be located in the table about students. This enrollment only who takes what course. Similarly, about the course, who teaches that course, not necessarily in this enrollment tables. Who teach that course may be different tables. So they are directly related or indirectly, but anyway, in a database, then they are somehow related, right? This table related to another table, which can in turn relate to another table, then first table and third table may be related indirectly. So you have a collection of data with database, and you have MySQL, like DBMS, database management systems. If you populate your data using MySQL, database management systems, then we call that database system. We call systems because the data in MySQL. So that is database systems. MySQL itself, which does not have any only the software packages, we call that DBMS, database management systems. So in order to design or in order to create a database, then we need to first look at on an application domain, a small world, right? As I said, university database, or registrar's database, or payroll database, or patient database, hospital database, all kinds of database, booking.com database, right? Then you have to, each such a small real world application domain, data generated, created, and needs to be maintained, managed efficiently, or some other cases it needs to be maintained securely. At another point, it needs to be stored more permanently, therefore should be accessed later if we need to, for some reason, maybe audit tracking, or maybe in response to users' request. So all such scenarios are applicable. So we need to store the real world data effectively and efficiently. Effectively, therefore, it can be stored the optimal size of storage. Efficiently, data can be retrieved timely with no delay time. If I go to the airplane ticket counter and I show my passport, if there's no information about me, or although I registered, I purchased, but if it takes 1 hour or 2 hours, then it's not really acceptable, right? It should come out quick, right? Efficiently. Swipe my passport quickly. The ticket counter says, generate the tickets, boarding pass to you, right? Efficiently, it should be retrieved. It should be stored effectively, right? So it doesn't cost much. For all such things, don't forget the securely also, right? If your data is compromised or tampered, then that is your loss, right? But anyway, so we have to analyze the real-world application problem carefully. So as you see here, this is simple simple design. We call this ER diagram, entity relationship diagram. What that means is that we have a box and diamond. Box is like a subject and objects, and diamond like a verb. So students enrolled in a course, right? So subject, verb, and objects, something like that. That is ER diagram. Have you heard of ER diagram? Yeah. So that is ER diagram. In this course, we don't practice much about this because we simply we have another course. So yeah, just to help you understand what it is. From this ER diagram, we call that a conceptual design. This is a logical design. Logical means then from here we can say students can be defined over CWID, student name and major. This course can be defined over course title, CRN, course I think course number, CRM means course number, right? And credits and instructors. So student table and course table. Box can be a table. So student and course. Diamond can be a table, separate table, or sometimes it could be emerged into, could be combined in, could appear in one of those boxes. But in this case, could be one separate tables. So this table explains who takes what course, right? Only this enroll table has two columns. CWID comes from these students, and CRN comes from this course. So by looking at this, CWID, some number, matched with the CRN, another number. By looking at this enroll table, we do not know who, but we know what number takes one number, right? If we want to see what is the course title, then because we know this number, bring that number to this course table, match that course number, then we may be able to see course title. Similarly, looking at this CWID number itself, we do not know what is the name of that CWID. Only when we bring that CWID number to student table, then we may be able to see who that person is and what major that person is studying, right? So student and course, these two tables are not directly related, but indirectly. Student table connects to the course through this enroll table, right? If you come back here, ER diagram, then you can see students and course, two separate entities, but they are connected in this specific example by this diamond called enroll. So student and course, two tables are connected through involvement relationships. They could be related to another through another relationship, not necessarily only one relationships. Between the same two entities, we could have another diamond. Not only this enroll, but we can say requirements, or we could say transcript. Enroll is currently enrolled, right? Transcript, then this student already took this course. That is another diamond. Then transcript could be another table here. So each of the relationships for entity sets has some of the meanings. So the meaning tells us some of the data flow of the real world applications. So the course enroll and students, we can have in this case, let's see. This is a simply well, we don't have any yet the creation. Okay, so we first create the database. Let's see here. I didn't have that. Okay. So let's practice it now. For Windows, I want you to bring up terminal, same as the Mac. I'm using currently a Mac. Are you using Mac or did you install?
Yes.
Okay. So bring up a terminal.
Have it open.
I'm not sure you already have the database activated. But you can check the database by looking at this. I think there's a system settings. For Windows, usually you do not need to. Once you install it, I think it is always, unless you stop running MySQL by default, when your system starts, then MySQL runs on Windows. Mac OS, same thing, but my case, I didn't activate it automatically. If it is the case, only if it is the case, then you need to see mine is not activated. Reason for that is, usually I do not use MySQL. You guys the same thing, right? Then you need to deactivate it. You need to stop it, usually. So only if I need to do, then I can start it. Then it asks me to enter the password. is activated, green lights on. Once it is done, then for Windows, as you guys turned in the first homework assignments, you need to do the same thing that you did. So change directory. I think for Windows, you need to do program files, backslash. You need to find out MySQL. Some of the location until you can find out MySQL binary files. So in our case, USR, let's say CD USR, and then ls, then you have a local, so CD local ls, then you have a MySQL, CD MySQL, another list. You don't see yet MySQL, the process program. So CD bin directory, which is binary files, change directory to bin, and then finally you can see ls, then there's a MySQL. So here MySQL. So CD, now you need to run MySQL. MySQL -u root. We are not going to create the users, the granting user privileges, things like that here in this class. All those things needs to be done in another class. But simply, this class we are working on as a root, and -p to ask password. But if I do this on the Mac, this works for Windows. Once you get into the location where there is a MySQL, you can simply type this. But it's not going to work for Mac OS because it's a Linux. Watch this. It does not know where it is. All right. So in this case, you need to explicitly where that MySQL file located. So you need to do dot and slash. What that means is that I want to run this MySQL specifically here at this location. That's what it says here. Dot means current location. In the current location slash MySQL. I want to run specifically this MySQL. Then it asks me. Right? Initially, I want to see any database systems are created. So show databases. By default, you have information underscore schema, MySQL, performance underscore schema, and SYS. Those four database systems are called catalog databases. Those are the databases contains data about this MySQL itself. For example, when you create your database, then this MySQL database itself needs to know the name of the database that you created. All those catalog needs to be stored somewhere. Although you are creating your own database, but this MySQL has another catalog database that handles, that knows your database. Not the database data details, but some about metadata about your database. Metadata. Okay, MySQL DBMS needs to know something about your database that you are currently creating. We call that meta. Okay. So those are metadatabase. So we need to create database. Language is this: create database. And what are we going to do? Maybe registrar. Registrar. Create database registrar. And if you want to, this is a language. Create is a reserved word. Database is a reserved word. In this case, we are going to create database. Okay, database is an entire umbrella. In a database, you could have one or more tables. Create database umbrella and get into that umbrella. Inside, you need to create tables. So create this, the language create could create database, or some other times it could create table. Okay, so next time we will use table, but in this case we will create database followed by, this is a real name. Registrar is my own name. Create database, that is a reserved word, like a command. A registrar is my name. And then we can put, we can hit enter, but if you hit enter right now, then MySQL still waits until you say semicolon. So semicolon is delimiter. When you say semicolon at the end, it tells the MySQL, hey, this is complete statements. Without semicolon, for example, if it is a long statements, you cannot describe all in one line. You want to make a hit enter and create another second line, third line, fourth lines, because that is a long list, long statements. Still waits until you say semicolon. When you put semicolon, then it executes. For example, if I didn't put any semicolon, if I hit enter, then it still waits until I say semicolon, hit, then it says create one affected. Show database. Then now I can see registrar, my database. What should we do now? You need to create table, right? But before you create table, you need to, because how many databases right now? We have 5 databases. So you need to see, you need to choose first. Hey, I want to work on this specific database. So to choose it, you can say use registrar. And don't forget to type semicolon, hit enter. Then database changed. Now show tables. See if I have any tables. No tables. So you need to create tables. Let's say create student tables. So create. Now we need to say table. And table name is a student. And then you can say, in this case, you can hit enter. And CWID and integer and name. You can say type of this language here, create table followed by table name and open parenthesis followed by pair of attribute name and type. So CWID attribute name, see here attribute name, CWID. And then type is integer. Name, type, you can say character or variable character. If it is a variable character, then what is the size of that? You can say 25 bytes long. And then major, variable character, character 25, then it allocates 25 bytes for name. Variable character 25, then within 25 character, if it is short, for example, Adam, 4 bytes only, then use 4 bytes only. The rest can be still available for other uses. There's a variable character. Another similar thing is text. Then you don't need to worry about the size of text is similar to variable character, but it maximizes the size. What is the maximum number of the text type? That is 65,000 bytes. Useless, right? But it's easy to say if you don't care, simply text rather than varchar 25, varchar 35, varchar 225, things like that. But so this is another thing that you could do. And hit enter and semicolon, then that is created. So if you say show tables, then you have one table, students. And then if you want to see the table definition, I mean the student table definition, then you need to say describe. DSC for, there's a short for describe. Describe student. Then it tells us CWID, type integer, name, varchar 25, major, text, null, it could be null. Default, there is no default values. That's fine. But there's no, which means I can create here. Once I have that students table defined, then I can insert the values. Insert into student values and then I can say integer 1, 2, 3, CWID 1, 2, 3, and then varchar Adam, and then major cyber. I'm looking at now this first column here, CWID 123, name Adam, major cyber, and hit enter. Then it is created one enter, right? So if I do select, so integer is another language that I want to load the data in a table. In a nutshell, what we have done so far, we create database. We use one database. We choose that database, and then we create table, and we populate one data using insert into the specific table. And then I want to see the content of that table. Then we need to use a select star from student. Then I have 1, 2, 3 Adam Cyber. That is exactly that you have here, right? I need to go back here. What if I do like this? Have an error, SQL stacks check the manual that MySQL so for the rest next Adam at one line, because I don't have anything. But if I have here null, null means nothing, right? That is possible here. Null and do one more. And one more. I want to see some unrealistic things so that we need to fix it. When I select star from student, this kind of table accepted. If you're looking at the real world example, CWID, there's a student ID. 1, 2, 3, first row, fine. Second row, no CWID, but using the same name, same major, okay. Same name, okay, right? But CWID, how many nulls do we have? 3 nulls. Let's say null is CWID, acceptable ID. But there is no duplicates, shouldn't be duplicated. 2 students use the same ID? No way, right? But null itself, it means something. It means not, null means null, right? Empty. What if there is students who do not have CWID? Would Mercy University accept any students with no CWID? No, no way, right? How can we manage that? That is the issue. Right now, this is not right, right? So what should we do? Okay, first thing that we need to do is show tables. So we have students. I want to remove these students. So I want to redo. Okay? So how can we remove this table? Delete is accepted the language, but delete doesn't delete table itself. Remember that on I think Excel or Microsoft somewhere there, if you want to remove some rows, some cases it asks you to, do you want to remove entire row, or do you want to remove the data itself?
Yeah.
What do we need to do? Are we going to delete this data only, or are we going to delete entire structure so that we need to delete entire structure, therefore we need to fix this. Right?
Yeah.
So delete can delete data itself. Another language that we need to use, it is called the drop. Drop table student. Show tables. There is no tables now, right? So we have to redo. Now, what we need to do? What do we need to do? If you're looking at the real world, in the table, CWID needs to have somehow primary keys, right? So each student should have a unique ID. We call that primary key. Primary key, by definition, it is unique, and also it should be non-null. If we say primary key, then it should be non-null. So primary key is very, very important. Another case, if you want to see non-null, then you can say non-null. For example, major non-null, or name non-null. But primary key is important, right? So let's do that. By the way, I want to guide you to somewhere here. No. Okay. w3schools.com .com or .org? I think it's .com. Okay, go to SQL, or here MySQL. Not just SQL, but MySQL. Then you have here, I want to practice this, because this is not database course itself. I want to simply guide you, right? We spend more time on coding, but as database, we simply, so here, MySQL, okay, create table, MySQL database, create table. Then you may be able to see here something that you can see here, drop table that we practiced it, some of them modify and things like that. But anyway, basic syntax is it's like this. So you can practice it more if you want. But right now we redo create table student, and then CWID integer. So far that is okay, right? And then name, I would say simply varchar 25 non-null. I'm not sure non-null is allowed. Let's check. anomic SQL non-null constraint.
So it is not null. And
Not null. Not null. If you do not allow, say name null, then you need to say this. But major, okay, varchar, let's say 10. Okay. Major, that could be null major. Initially, you don't need to declare, right? Non-declared major. And then you need to, so we have three attributes defined with the type integer, varchar not null, and varchar. And if you want to do primary key, then you need to do primary key. And which one that you want to use primary key? CWID. And then finally, you need to close the parentheses and ending with the semicolon and hit enter. Successfully done. So if you want to see that student to description, then see non-null not allowed, no. For CWID, name non-null. CWID, there's a primary, PRI. If you compare that with this, then we fixed it, right? Now we need to see insert into. This is okay, right? Insert into. No problem. And if we do null here, see what happens. Previously, it was accepted, right? But now, column CWID cannot be null. What if I do 1, 2, 3 again? 1, 2, 3, but it's not Adam, say Peter. It says duplicating entry 1, 2, 3 for key. So it should be primary key. I mean, because of it is defined as a primary key, it should be unique, right? So to fix it, we can say different number, 1 to 5. And at this point, if you want to see select star from student, then very nicely we see here 1 to 2 rows of this student. So I wanted to insert to the other 2 rows right now. Oh, great. Okay, next thing that we need to do is we need to create a course. Course. So create table course and title. I would say text any length up to 65 bytes long. And then CRN integer credit int instructor varchar, similar to the type for student name. Student name, the type for student name is varchar 25. Same thing, instructor's name. Anyway, same type as student name. So we use 25. Anything missing here so far? What about the primary key? Primary key should be CRN. And then we need to close entire parenthesis and semicolon. Show tables. Two tables created. Description of course. Okay. Similarly, we need to create table CWID int CRN int and create it. Create table name enroll. Show tables, 3 tables. Now we can do insert. Let's first insert first insert into course values. If we want to insert, for example, CRN title credit in this order, values. Remember that we insert into a student and value. We didn't do anything here, but the values that we entered are exactly the same as it was defined, right? CWID and name major. If we want to do in that order, the way that it is defined, then it is okay. But if we want to switch, for example, CRN first, and then followed by title, credit, and then instructor is not inserted here. If you want to modify the way that you enter the value for some reason, then you need to specify here. If this order and number of attribute that is exactly same as this, instructor, title CRN credit instructor in this order, you don't need to do. But if you want to enter the values in different order, or not all attributes, then you need to specify that explicitly. Therefore, in this language, which values goes into where, right? So values, and then you can say CRN, I would say 555. Let's see. Let's try to do the way here. First row, simply the way there. Values and coding, CRN 111, credit 3, and instructor John. And then second one, database. Uh, 5 to 5. 3 credit John, fine. Third one, defense 550. 3 and Usman. Select star from course. Then you can see like this, exactly like that. But the way that I want to show to you, as I tried before, I want to put the CRN first and title, followed by title and then credit. No instructor. So that I have here 555, title, let's say mobile, and then credit 3 hours, and then no instructor. This should work also. So if I want to see this, then mobile, title, CRN 555, credit 3, instructor none. This is quite possible, right? For some time period, instructor may not be assigned yet, right? So with that, now next one is we want to see who is taking what course. So that is nothing but another insertion into the table enroll. Insert into table enroll, values, and then we can say 1, 2, 3, 1, 1, 1. Fine. If I want to see here 1, 2, 3, 2, 2, 2. Can you see any issue here? Thing is this, we have these are the course list, but this guy 1, 2, 3, who that 1, 2, 3 is? 1, 2, 3 is if you go all the way up here, Adam tried to enroll the CRN number 222, which is not available in our course list, but still possible Database, data, if it is in our database, DBMS, then it should be efficiently maintained. So what is missing right now? What is missing here is, if you see here description, enroll, CWID simply null possible. We could fix this, but this is not null. 222 is not null. So even if we say not null, we cannot avoid this, right? What is the reality? Anything that you want to take, then that course should first available in the table, right? It should first available. Not only that, let me see here. What happened here? This student, CWID, is not in the students list here. So there are all kinds of issues here, right? So what is the thing here? This enroll table, like here, student and course, this enroll diamond relationship, anything that needs to be entered here in this relationship relates only something available in this the entities, right? Because this diamond relates the left side box student and right side box course. We don't say this diamond somewhere invisible, right? Something that is available here, student, something that is available in this course can be related, can be, this is a relationship, should be related. But in our example, here, it doesn't implement that. So let me drop table enroll right now. So we need to create table enroll, and then what I want to do, I want to bring that create enroll. Okay, this is the thing. I want to use this as so far. CWID is integer, CRN int. Remember that previously we looked at primary key. CWID, what is CWID? CWID is the primary key in another table. CRN, exact. CRN is the primary key in another table called course. Here, CWID and CRN is somehow, they are not really primary key, because CWID is borrowed from student table, and CRN is the attribute borrowed from course table. But if we see their original table, then they themselves are primary key. Currently, here in this foreign country, like enroll, their own home country, then they are primary key, they are king, or they are prince, or princess. But because they are here in the foreign country, they are not anymore prince or anymore princess. But somehow we need to say, by the way, you were prince or princess when you originally in your home country. We need to say that. By saying that, this guy can check. Hey, there's a no, if somebody says 333 students enrolled in the CRN 222, then this guy says, hey, 333, before you enter here 33, you first created it in your home country. CRN, before you take it, that CRN needs to be first created in the course table. After that, you can take it. You cannot take any course before it is created. Anyone before it is registered as a student cannot or is not allowed to register. Okay, so that is a foreign key. So to do that, foreign key CWID references CWID comes from student CWID. That is the language. Similarly, foreign key CRN reference. CRN comes from courses. Course CRN. And finally, we need to close entire statements and ending with the semicolon. Hit enter. Then if we see the description of enroll, then it says previously key CWID and CRN key is not specified here. More. That is, I think it's a mutual, but mul may be for mutual. So mutually, they are some of the constraints. Okay. Or multi, mutual, whatever. With this, if we insert, I'm gonna go back to that insert. Okay, insert enroll 123111, fine. And then if I do insert, for example, 333222, what happens? If I want to insert to 333222, then it says cannot add or update a child row, a foreign key constraints fails. So it doesn't allow, right? Only we can get here 1, 2, 3, 5 to 5, and 1 to 5, 5 to 5, 135, 5 to 5, 1 to 5, 550. So we have that. Okay. So we have databases ready. Now I want to see, for example, who takes what course. This SQL statements, select star means I want to retrieve all the columns. If I want to retrieve only CWID, then I can see CWID only, right? Star means all the attributes in this table. So select followed by number of attributes, list of attributes from, there's a reserved word, followed by table. Right now we have only one table, but you can have multiple tables. If you have in the from closer, in the from closer, here in the from closer, if we have more than one table, those tables are joined together. Where clause, we didn't put any where clause, but if I want to say select star from enroll where CRN is greater than 500, then I can see only 500. Remember, I have here 5 rows, but because I have this condition, CRN number should be greater than 500, so less than 500 is cancelled out. So select from where clause is needed. Now we want to see who takes what course. So before we do here on our MySQL, we need to think of who takes what course, so that who means here name, course means here title, right? Title and name, those are what we want to extract. But these two tables, student and course tables, those two tables are not directly related, but indirectly through enroll. What happens here is that if CRN here 111, then that CRN here 111, right? Therefore, we know 111 is coding 111 is taken by 123. Who is that? Adam. Adam is taking coding course. Okay, so 3 tables are needed. So select. We need to have a title. We need to have a name and title from course and enroll and student. Where CRN is greater than 500. Let's say like this. In this case, CRN causes ambiguous why it may occurs two places, right? CRN here course, CRN here enroll. So we need to specify which CRN. We can say course.crn. Only we can say, if you want to specify this CRN that is available in this specific table, then you need to say here table name dot attribute name. So dot notation is needed. Hit enter. Oh my God, what happened? What happened? Tell me. What I want to do here, tell me about this. What I want to intend here, who takes the undergraduate course? Who takes, let's try to do somewhat more realistic. Who takes undergraduate courses? Less than 500. If you see here in this table, who takes undergraduate course? Takes the enroll. If you come here enroll, then only 111 that is taken by 123. So Adam is the only one to take the coding course, right? If you see here, David takes coding course. Chris takes coding course. David takes coding course. Peter takes coding course. Adam takes coding course. Chris, what happens?
Just assigning the title to everyone. That's less than 500.
What is missing here is join condition. Join condition. If we see here, I'll show it to you. Select star from course, enroll, student, hit enter. It gives me all possible. This gives me all possible matching. All possible matching. So if you want to see any realistic relationships, then you need to specify join condition. Join condition. What that join condition here is, okay, here, and then you can say where, which one is what? CRNs, this CRN should be that CRN, right? In order to do that, I want to refix here. I want to see here some of alias. Course, rather than we spell out course, I want to use it C, like alias. E for enroll, C for course, S for student, and where C dot course dot CRN should be the same as enroll dot CRN and student.cwid equals enroll.cwid. And course.crn is less than 500. Therefore, we may be able to see who takes undergraduate course. If you hit enter, very nicely, Who takes undergraduate course? Only Adam, right? Here, Adam. In other words, if you want to show that, only the name and here student dot name, comma, course dot title, and simply we see Adam takes coding. Only that student takes undergraduate course. So why, without that, let's consider join condition. Join condition. Remember that this is a join condition, right? From here, this is a join condition. C.crn equal E.crn and S.cwid equal E.cwid. That's join condition. Real application condition is CRN is less than 500. This is a real condition that we want to see, right? Who takes undergraduate course? But this, the other two the conditions are, it should be specified but not directly related to our query. That is the description about join, table joins. It would be much nicer, MySQL or SQL query, the language itself developed automatically without having to specify join conditions. Always, if we say multiple tables in the from closer, if we have multiple tables in the from closer, then it means I want to join them. Therefore, simply automatically that can be generated. Like currently we have machine learning technologies developed and ChatGPT is available. Why should we explicitly specify that always when it comes to join operations? If it is join operations, then why not very nicely automatically derive that? It's not difficult at all. Someone may ask that questions. Right? But database operation is like set operation. Usually we do joining operations. But what if we say not joining? Some other query may say, this database tells us who takes the course, then we join them, right? What if some other says, who does not take the course? That may be possible, right? Then we need to manipulate that in this kind of, we need to look at entire possible match combinations, and then we need to eliminate, we need to cancel out some. That process is needed. We need to start from full set, and then we try to eliminate, depending upon the type of queries. Therefore, the language is not developed in that way. So we need to always say, if we want to do join operations, then join conditions needs to be included. Otherwise, it gives you all productions. We call that Cartesian products. It products all possible combinations. I think, so with that, the next one is to more little more complicated queries. So I think we need to stop here today. And then we'll continue to do it. And then we'll complete next week. And then we do